Hello, this is Mrs. Hickman, and for this video session, I'm going to be going over the extreme value of functions and the mean value theorem. So first, extreme values of functions are talking about extrema. So extrema are where you see maxes and min as you see in front of you. So the extreme value theorem says if f is continuous on a closed interval a to b, then f has both a maximum and minimum value. Okay, so we see value, so value just means there's a defined point. So it has to be a closed dot. You can't have any holes. So a open hole cannot be a relative or an absolute max, as you see. It has to be defined. So the absolute maximum value, sometimes called global maximum value, but in calculus we're going to just call it the absolute, or just the maximum, okay? Well, I guess we'll just call it the absolute max just for clarity's sake. Okay, is going to be the highest y value on the point, and it only happens once. So right here, you see that the highest y value is right here, so that's going to be the absolute max. Now I want to say something. If you have like going up to infinity here and over there, you're not going to have an absolute max because you're not going to know what it is because it keeps increasing. Okay. So we're just going to assume this is the closed interval we're looking at from here to there. So we're not going to worry about what the sides are doing. Okay, so our interval is going to be from 1, 2, 3, 4. We'll do this one too. 1, 2, 3, 4, 5. So we're going to be looking at the interval -5 to 1, 2, 3, 4, 5. So -5 to 5. Okay, so absolute max is the highest max. The absolute min is going to be the lowest point. Okay, so that's how you find the absolute max and the absolute min. These could also be end points, okay? So if this went up the whole way up here, you would have an absolute max up here, okay? So we went over the absolute minimum, okay? And so then you see relative max and min. Now, these can also be absolute max. So relatives happens wherever you see a trough looking thing. So anytime you see like a mountain anywhere, okay? So a relative max is going to be, one's going to be here, here, and there. Okay, so anytime it has a frowny face. Relative minimum is going to be anywhere you see a smiley face. Okay, so right here and here. And these could also be endpoints. Never mind, it has to be an interior point of the domain. Okay? Alright, so let's move on to other things. So the interior domain points where the function, okay, so local extreme value theorem. So I don't know if you remember when we were drawing graphs of derivatives. So let's try to draw a graph of a derivative here. So I'm going to do print screen. Go to paint. Okay, so if we were to draw the derivative here, the first thing I told you to do is look and see where you see max and min, or where you see that the slope is 0. So if I was to draw the derivative of this graph from -5 to 5, of course, right here. So let's see, that's going here. The slope is negative to positive, so I'm going to be crossing like this, like that. Okay, I see another place where the derivative is 0 here. Okay, and it's going from positive to negative. So it's going to look like that. Here's another one. The slope is going from a negative to a positive. Looks like that. And this one's going from a positive to a negative like this. So the derivative is going to look something very roughly like this. See, as I said, it's very roughly. Okay. Okay, yeah, it's not supposed to be curving, but you know, it's a computer. Alrighty, so the extreme value theorem, let's point at this. Okay, so the extreme value theorem, if a function f has a local maximum or local minimum value, of course this also includes absolutes, at an interior point of its domain, And if the derivative exists at c, then f prime of c equals 0, okay? And at this place where the derivative equals 0 is going to be points called critical points, okay? Now these can be defined or undefined. Undefined is going to be any values where the denominator is going to equal 0, or where you see that if you have like a square root function, square roots can't be negative. So that's what we're talking about defining the domain. So let's review some domain values. So A and B here is talking about just the numerator, okay? So this is just the numerator here. Okay? This is talking about the denominator. Okay? So any odd root you have, like cube root of x, like if you just have fx equals cube root of x, that the domain here is negative infinity to positive infinity, okay? So anything that has an odd root or is up to a radical is going to be polynomial functions like x squared plus x plus 3, x cubed plus 3x plus 5. Their domains is negative infinity to infinity, which means any x value you put in there will give you a defined y value. You will have an x value and a y value. Okay, so what if we have an even root? Like if we have I don't know, square root, so f of x equals the square root of x plus 2. Well, the domain is going to be anywhere where x plus 2 is greater than or equal to 0, because square roots can't be negative, so your domain is going to be x is greater than or equal to negative 2. That's going to be your domain. Okay, so let's look at the denominator now. Sorry, cord in the way. All right, so denominator. So expressions in the denominator, not an even root, just set the denominator to not equal to 0 and solve. Okay, so I made a little example here. So if f of x was 1 over x plus 2, you're just going to do x plus 2 can't equal 0, oops, and x can't equal negative 2. So any x value will do, it just can't equal negative 2. Okay, so what if you had a radical, an even root radical in the denominator? Okay, well, you set that to just greater than 0. Yeah. So you set the denominator greater than 0 and solve. Okay, so note here, so let's say you had, it doesn't have to, so let's say you have like the square root of 4 minus x squared here, which we'll get to later. This is kind of what you do. So this is kind of, if you have like a square root, is greater than k. This also works with the greater than or equal to. So you square root both sides, you get plus or minus k. This is an absolute function. This is going to help you with your sign chart, which we're going to get into in a little bit, okay? So you could check using a sign chart using this way, or you can just make it into an absolute value function. The absolute value of x is greater than k, which is going to give you, so you're going to set whatever is inside the absolute, x is greater than k, or x is less than negative k. Here you have the absolute value of k is less than k. This would be if like you had like a negative there, then it would be negative k is less than x is less than k. Okay, so that's anywhere that would be defined in the domain. Okay, so from negative k to k, that's where underneath the radical is positive. Okay, OE, even root radical in numerator, just note the algebra above. You just said greater than or equal to, so we did that right there. Okay, so now we're going to be finding the zeros of f prime, or what we like to call the critical points. Okay, so you have f, you found your derivative, you found your f prime. So now you're going to set the factors equal to 0, okay? So get really good at greatest common factor and just factoring in general. It'll help you. And set anything that's a negative root into the denominator. Alrighty? So anyway, you found the derivatives. You set them equal to 0. Radical in the numerator, you're just going to follow these same steps up here. So that's just going to set the expression under the radical to greater than or equal to 0. If the numerator, and if it's just like an x in there, just set it equal to 0. Okay? So this is the same thing. Set the factors equal to 0. If you have a radical, set it greater than or equal to 0. Undefined values of f prime. So these are going to be in the denominator. Okay? Because that's where x is going to equal 0. So C domain up here. Same thing. Okay? Sign chart. So if you haven't seen a sign chart, it's where you make intervals and stuff, and I will show you how to do that. So sign chart of f prime. So x value of critical points occur when the signs change. In the next video, you're going to see that the signs are going to be where it's increasing or decreasing. So 5, you're going to verify if f is differentiable at above values, okay, which means it can't have a cusp, a corner, or anything like that there. Determine y value. So evaluate the x value found in step 4. So when we find our x value, that's when the signs change in between. You're going to be putting the x value you found in the derivative into the original function. And critical versus stationary, pretty much critical points can be differentiable or non-differentiable. Stationary points can only be differentiable. Right. So let's do an example. I need paper. There's paper. Okay. So the first example we're going to do is f of x equals, oops, f of x equals 1 over the square root of 4 minus x squared. Okay, so first thing you need to do, you need to determine the domain of this function here. Okay, so step 1, find the domain of this. Okay, numerator is fine, denominator is not. So you have a radical in the denominator, so domain of f. Okay, so you're going to have 4 minus x squared is greater than 0. Solve for x, you're going to get x squared, negative x squared is less than negative 4. Divide by negative, that's going to switch the sign. Oh, I already switched the sign here, my bad. Less than negative 4. Okay, square root both sides. So you get x is less than plus or minus 2. Here, let me start that over. Negative x squared is greater than negative 4. X squared is less than 4. So x is less than plus or minus 2. There you go. Okay, so this is going to be the absolute value. So the absolute value of x is less than 2. So with the less than, you're going to set it up like this. Negative 2 is less than x is less than 2. Okay, so this is going to be the domain of everything. You cannot go outside this domain. So that's the domain of f. Okay? If you want to make a little list up there, you can. Domain of f. Okay? Now we can find the derivative, or where we're going to have extrema. Oh, here we're finding the extrema. Okay? So we've got to find the domain of f first. F prime. Now in other math classes, you've had to use a calculator to find where maximum and minimum are. So in calculus, you're going to be able to calculate that. Fun stuff. So finding f prime. So first I'm going to make that a negative exponent. Also, just a tip before we get here, if you can use the product rule, use it. So that's going to be 4 minus x squared to the negative 1/2. Okay, so you're going to be doing a chain rule here. Okay. U is 4 minus x squared. U prime is negative 2x. F of u is u to the negative 1/2. F prime of u is negative 1/2. U to the negative 3/2. So f prime of x is negative 1/2 4 minus x squared to the negative 3/2. Okay, so f prime of x is going to be negative 2 times that. So you have negative 2x times negative 1/2. That just gives you negative x times 4 minus x squared to the negative 3/2. Okay? You see a negative exponent, so put it in the bottom. So your derivative is negative x over 4 minus x squared to the 3/2. Okay? Now you're going to find your critical points. Okay? Critical and stationary points. So remember, anywhere is differentiable. Right now, this function up here is differentiable anywhere. So whatever points we see down here will also be stationary points. Okay, so let's look for defined values, or you can call those zeros of f prime. So we'll do zeros and undefined. So zeros is going to be just set the numerator equal to 0. So it's going to be negative x equals 0. So x equals 0. And then the undefineds, okay, so we already kind of went through this algebraic process. This is an even root, so you're going to set it to greater than or equal to 0. I mean, just greater than 0. You can't be equal to 0 because it's in the denominator. And from what you saw up here, you're going to get negative 2 to 2. Okay, so now we're going to see where the critical points, we're going to see if there is a critical points. And that's going to be if the sign is changing. So we're going to do our sign chart here. So this is going to be a sign chart of f prime. And remember that f prime is negative x over 4 minus x squared to the 3/2. On the AP Cal exam, they're going to want to see a table here. They're going to want to see you evaluate the values here on the AP exam. So just watch out for that. Okay, so our domain is going to be negative 2, 0, and 2. So our intervals here are going to be negative 2 to 0, 0 to 2. Okay? So you can just go and put your intervals here. So let's check from negative 2 to 0. So you need to check an f value. So f prime of... choose a value between negative 2 and 0, not negative 2 or 0, so negative 1. That's going to give you negative times negative 1, you're using this right here, over 4 minus negative 1 squared to 3/2. Now the great thing about already doing the domain here, we already know this is going to be positive, okay? Because this has to be positive or it's going to be outside the domain. If you don't believe me, you can do it because it's going to be positive, okay? So you have positive over a positive. So that's going to tell me that in this interval, I have a positive, okay? Or, wait a second, negative times negative 1. Oh, I found a mistake. Negative times negative is a positive. It's positive. Sorry. Positive. 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 So that's going to be a negative. Okay? So this is going to be where the function is. You'll see in the next step, this is going to be where the function of f is going to be decreasing because it's a negative. Spoiler alert. All right, so now you're going to try the interval 0 to 2. I mean 0 to 2, positive 2. I don't know why I put negative 2 there. 0 to 2. So f prime of easy number is 1. Choosing a number between 0 and 2 is 1. So you're going to have 1 over 4 minus 1 squared to 3/2. So that's going to be a positive over a positive, which is a positive. Hey, great news. You have a critical point here. So right here, you're going to have a minimum value because you're going from a negative to a positive. Okay. Alrighty, so now, great, you have a critical point. So critical and stationary point, because it's differentiable there. You're not going to worry about the stationary points too much after this chapter. Is going to be at x equals 0. And to find the extrema, you have to go back to the original function. Okay, so this is where the signs change. You would check the endpoints if they were defined, but they're not. Why are they not? Because it's just a less than. If it's equal to, then yes, you would need to check them, because extrema can be that. So f of 0. So remember, f of x is 1 over 4 minus x squared, which is going to be 1 over the square root of 4 minus 0 squared, which is going to be 1 over the square root of 4, which is 2, 1/2. Okay, so you have a minimum, I would say absolute and relative, or you could say local minimum at 0, 1/2. Okay, so if you were to put this function in your calculator, it would look something like this. Okay, so 0, 1/2 is, we'll just sit right here. Here's -2, there's 2. It kind of looks like this. So it's like vertical asymptotes here. Something like that. Okay, so that's 0, 1/2. You gotta, that's your lowest point. All right, let's do another example. Okay, so we're going to do f of x is x to the 2/3. Okay, first things first, find the domain. So the domain of f is going to be negative infinity to positive infinity, because it is a odd root. Okay, is it differentiable everywhere? No, it's not going to be differentiable at 2/3. It's going to be a cusp thing. Okay, so it's going to look something like this. Okay, that's going to be what it looks like. So right here, it's not differentiable. So that means there's not going to be any stationary points. So no stationaries. But there is going to be a critical point. Okay, so let's find what that critical point is going to be algebraically, not by looking at a graph. So say we didn't have a graphing calculator, you didn't know what this looks like, this is how you would find it. So to find the derivative of f prime, so f prime of x is going to be 2/3 x, 2 minus 3 is -1/3. So f prime of x is 2 over 3 cube root of x. Okay. Now you find your zeros and your undefines. So for the zeros, you look at the numerator. So 2 can't equal 0, so there's none of those. Undefines, you set the denominator to not equal 0. So x can't equal 0. Okay, so it's undefined here, but it is defined there. So remember, this is just, so of course that makes sense. It's undefined because it's not differentiable there. It's going to be a vertical line. But why we're doing this is we're connecting what f prime, we're connecting what is happening at f by f prime. So it's not differentiable there, but there is a critical point there. So now you do your sign chart of f prime. Okay, and you look at your intervals. So everything's negative infinity and positive infinity. So you have on your interval negative infinity to 0, and then you're going to have 0 to infinity. Okay, now you're going to check your signs. So you need a value less than 0. I'm going to do, I don't know why I put it, I'm going to do f of negative 1 because it's easy. Just make it easy on yourself. So 2 over 3 times negative 1 to the 1/3. Okay? Well, anything that's negative to odd root is going to be negative. So you got a positive 2 over negative. So this is going to give you a positive answer. That's going to give you a negative answer. So this is going to be negative right there. Here, f of 1 is 2 over 3 times 1 to the 1/3. Okay? So that's going to be plus over plus is a plus. So you have a critical point because you have a negative and a positive. Okay? So it's going to be a minimum. So you're going to have absolute and relative minimum at, well, 0. Now we're going to find the point. So to find the y value, we put it into f of 0, which is the original function here. So you have 0, and then you have 0 to the 2/3, which is 0, 0. Okay, and there you go on that one. So that is the extreme value theorem. Okay, and moving on to the mean value theorem. So since we're already on this whole finding things like extrema, I'm going to show you something else. Increasing and decreasing functions. So I kind of already go over this, but more examples won't hurt, right? So increasing and decreasing functions. So as long as the original function is continuous and differentiable on a closed or open interval, okay, you can tell what the intervals are increasing and decreasing. So this is all for f prime. So if f prime is positive, like here, so here's what this was the last example. So if f prime is positive at each point, then f is increasing on a to b. So in this example here, function f is increasing. So it's going to be increasing on this interval. F is increasing. Never mind, that's negative. So right here's the positive one. Increasing. You can see. On 0 to infinity. Okay? And then this is negative, so that's going to be decreasing on negative infinity to 0. Okay? So if it's positive in the sign chart, it's increasing. If it's negative on the sign chart with the derivative, it's decreasing. If it is 0 at the point, then there is a constant c for all x in a to b. Okay? So here's a little brief thing. So here's c. Here's your critical point, 0 or undefined. So if you had a plus sign there, that's increasing. If you have negative, that's decreasing. Extrema is found by, here's c, and then you put into the original function. And then increasing, decreasing values of f, intervals of critical points, okay? Okay, so if I was to draw I could actually draw the graph on this by just its information. So I have a critical point at 0. It's not differentiable, so it's either going to be a corner or cusp here. It's decreasing from negative infinity to 0, and it's increasing from 0 to infinity. Okay, that's f. Okay. All right, so we're going to be finding the local extremum and intervals which f is increasing and decreasing of this function here. So first things first, domain of f, that's going to be negative infinity to infinity. Okay. Next, find f prime. Okay. Set the derivative equals 0. So you're going to have a critical point at 1/2. All right. Well, let's look at that. Okay, so your intervals are going to be negative infinity to 1/2. It's just easier to see the intervals here. That's why I do them. So you have intervals this is f prime, intervals f prime of a value, sine. Okay, that's kind of how I do these. So you have negative infinity to 1/2. Pick a value between there. I'm going to choose 0 because it's easy. Just put it right here. So f prime of 0 is 2 times 0 minus 1, which is going to be a negative value. And then you have, check the interval 1/2 to infinity. I'm just going to do f prime of 1. So 2 times 1 minus 1 is a positive. Congratulations, we have a critical point at 1/2. So C, so to find the extreme, so increase, let's do increasing, decreasing first. So this function is decreasing on the interval so the function f is decreasing on negative infinity to 1/2, increasing on 1/2 to infinity, and extremum, which is going to be a minimum, which you could have also looked at the end behavior here, positive, even, it's going to be a parabola. So the absolute and relative minimum, is going to be at 1/2 f of 1/2. So you have 1/2, so here's f of x up here, 1/2 squared minus 1/2 minus 12. Okay. Okay, so let's see, that's going to give you, I should have made myself more room, it's going to give you 1/2, 1/4, minus, let's see, 1/2, so that's going to be 2/4, minus 48/4. So that's going to be negative 1/4 minus 48, so that's going to be negative 49/4. Okay. Oh, also, don't fail to point out that there is no absolute or relative max. Okay. Probably should have done that on the other ones. The other ones also have no relative or absolute max. Okay? So pretty much the same thing we've been doing. We're just identifying what the negative and the positive means to the function of f. So if I was to graph this function, just using what I got here, no calculator. So I have 1/2 49/4. So 49 divided by 4 is 12.25. So that's going to be really high. Oh, it's negative. So we'll just put it here. Negative 12.25. It's my graph. I can do it. So 1/2 is right here. I'll put it right here. So there. So it's decreasing from there to there, and then it's increasing. Okay? And if you were going to look at the derivative looks like this. It's negative, and then it turns to positive once it hits 1/2. Okay? So that's what the derivative, right? So the negative just means that's where it's below the x-axis. The positive just means where it is above. Okay, we got another example here. Okay. So f of x is x to the 1/3 times x plus 8. We're still finding the extrema and intervals of increasing and decreasing. Okay, so domain. I would say, so that's negative infinity to infinity, and that's negative infinity to infinity. So I would go for the domain is negative infinity to infinity. Super. Okay. So that's domain, infinity to infinity, and beyond. I don't know if anyone else still thinks that, but I still think that every single time I say infinity. Okay, so what do we have to do? We have to do the product rule. Okay, to find the derivative of f prime. So, f is x to the 1/3. F prime is 1/3 x to the negative 2/3. So you do 1/3 minus 3/3. That gives you negative 2/3. And then you have g. Oh, another way you could do this too is distributing, which I actually think might be easier. I'm already on this. I'll just keep going. G. So another way you could do this would be to distribute that. G is x plus 8. G prime is 1. So f prime of x is f prime times g. So 1/3 x to the negative 2/3 plus x to the 1/3. Okay, not done yet. You have a common factor here. So for common factors, you go for the one with the smallest exponent, which is going to be that. So you're going to have x to the negative 2/3. So that cancels out. And you're just left with 1/3. X to the 1/3 minus x to the 2/3 is going to be 1/3 minus a negative 2/3, which is going to be 1 plus 2, which is 3/3. So that's just x. I forgot. X plus 8. Boom. Alright, well, let's start this over. Redo. Just learn from my mistakes. It's alright. So f of x is x to the 1/3. So I'm actually going to go for what I was going to do. I'm going to just distribute that. So that's going to be x to the 1/3 plus 3/3, which is going to be x to the 4/3 plus 8x to the 1/3. So f prime is going to be 4/3 x. Maybe I should have done the product rule. 4/3 x to the 4/3 1/3 plus 8/3 x to the negative 2/3. Okay? So I guess we could take out this thing. I'm pretty sure you could just like multiply it by 3 and take it out, but I can't remember. Alright, well, we'll just leave it there anyway. So we're going to take out the x to the negative 2/3. Okay, I'm going to take out a 4/3 too. Because 4/3 is the smallest one, you take out the smallest one. 4/3 x to the negative 2/3. So 1/3 minus negative 2/3 is just 1. Plus 8/3 divided by 4/3. So 8/3 divided by 4/3. Divided by 4/3 is going to be times 3/4, which is going to be 2. Wait, that's just x to the 1. X. It's just x. Okay. Alright, so let's check our critical points. So all we have is 0, 4 times x plus 2 over 3 x to the 2/3. Okay, so let's check our critical points. So zeros. So you could do 4 equals 0, or you could just do x plus 2 equals 0. So x equals -2. And then you have 3x to the 2/3 can't equal 0. So this is undefined. So x can't equal 0, but we have a domain of -infinity to positive infinity. Okay, so we got f prime. Don't forget that, because we're going to be using that next. So we have -2, which is defined, and 0. Okay, so for our interval, we have -infinity to -2 with a bracket. Okay, because that's a defined point. And then we have -2 to 0. I guess brackets don't really matter. Well, yeah, we'll keep brackets. -2 to 0, and then 0 to infinity. Okay, so your critical points are both -2 and 0. And these are also your stationary points. Well, there's one, never mind. The stationary point, you're not going to have a stationary point at 0 because of this 1/3. It's going to cusp, probably. Okay, so you just have a stationary point at -2. Okay, so now you're going to look in your domain. So f prime of -3. Okay, so we have 4, -3 plus 2 over 3 times -3 to the 2/3. Okay, so -3 plus 2 is a negative, times 4 is a negative. That's going to turn into a, well, -3 squared is a positive, so that's going to be a positive number. F prime of, let's see, -2 to 0, let's do -1. It's going to be 4 times -1 plus 2 over 3 times -1 to the 2/3. So that's going to be positive again because of that 2. And then you have -1 plus 2 is positive, so that's going to be positive. So we have negative, positive. 0 to infinity, just use 1. F prime of 1, 4, 1 plus 2 over 3 times 1 to the 2/3. Okay, so that is also going to be positive and positive. Okay, so there's no maximum in here because the signs didn't change. So all we have is this. Okay, so let's look at this. So increasing. So, well, yeah. So f is increasing. So f is increasing from -2 to 0. And you do not have to worry about brackets here because it's going to change from -2 to 0 here. -2 to 0, so I guess you can go in and make these brackets. -2 to 0. Union 0 to infinity. You can't just do -2 to infinity because it's undefined here. Union 0 to infinity. Okay, or it's not differentiable there, so it's increasing to about there. F is decreasing from -infinity to -2. Okay, and we have an absolute and relative minimum here. So there's going to be no absolute or relative max, but there's going to be an absolute and relative min. At -2, f of -2. Okay. F of x is up here. So you have negative 2, negative 2 to the 1/3 times negative 2 plus 8. Okay, so negative 2 to the 1/3 negative 2 up 1/3 times negative 2 plus 8 is negative 7.56. Okay, so that's where your relative and absolute minimum is. And you can check this on the graph by putting this into your y equals, and when you put in this negative 2, you're going to see negative 7.559526. Okay, so that is that for finding things algebraically. Okay. Okay, so now we're going to talk about the, well, we're done for now. I'll talk about this later. Okay, so just look at Runweb for your homework and have a good night.